And so we've seen how to find the distance from a point to a line in 2 space. Now we are going to extend that to 3 space. So here's the typical problem. Here is my line L. It's defined parametrically 1 plus 2t, 3 minus t, negative 1 plus t. Here's my point Q, and my point Q is 4, negative 1, 1, and this is in 3 space. And if you take a look, we've got the axes and we've got the line, and you can see the plane, the XY plane here, which is where everything disappears. Okay, now we need to find the distance from this point to this line. Now before in 2 space, we were using the normal vector, and we were projecting onto the normal vector. Now we have a little bit of a problem in 3 space, because what we have going on now in 3 space is that there are in fact a lot of normal vectors to that line. So these are all the possible directions that a normal vector can take to that line. In other words, it traces out sort of a plane depending on where the position vector is for that normal vector. Alright, so you can see that all of these vectors, a continuous infinite number of vectors, are perpendicular to that line. And so we are going to have to choose a different strategy to find out how far that point is away from that line. One thing I do know is that there is an orthogonal line that goes from Q and it intersects the line at P. It's just that I don't know where P is yet. So here's one possible approach to this situation. I'm going to choose a point that lies on the line, P naught here, and basically I can choose any point. So I'm going to choose a point when t is 0. So I'm going to choose a point 1, 3, and negative 1. So there's my P sub naught, and I am going to produce a line from Q to P sub naught right there. Now I really don't know, this Q to P line is still imaginary. However, this P naught to P line, I do have an idea. I can actually project onto it because I have a direction vector for that line. If I just look at my parametric equation, a direction vector in that direction is 2, negative 1, and 1. And so I can actually project that hypotenuse onto that line. And as you can see, this is my projection, the length of my projection here. I can find out the magnitude of this line. I can find out the magnitude of this line. So I can project the hypotenuse on this plane onto this line and find out the length of the base here. And then the distance is just the Pythagorean theorem.